By the way, welcome back. Hopefully everybody had a good long weekend, a good Thanksgiving. I'll take that as a yes for everybody who's here. People who are not here, I don't know what's happening. We'll see. All right. So, I want to give a couple examples. Can somebody, this is going to sound almost like a politician thing if you guys are aware, like back in the 90s when Clinton tried to change what the word is meant. Look that up. What does and mean? What does the word and mean? I like it. Connecting two thoughts. I like it. So if I said, I want you and you to come with me, you're both going to come with me, right? I like it. There's another way to think of the word and. So and you might think is like adding things together. So that's not the definition of and that we use in mathematics. In math, and is sort of like, I remember back in the day, nowadays you guys can search for scholarships relatively easily. I don't know if you do that. If you don't, you're a little silly. Right? But scholarships. Anybody search for scholarships at all? Yeah, a few of you guys? No? Like, free money. Who needs that shit? I don't understand you guys. Sometimes you just have to be who you are and you'll get money. It's insane. All right? So back in my day, we would go to the financial aid office and there's this book about this big that had all these scholarships and it was updated every half a year or whatever. I don't know. So you'd open the sucker and you start reading through and it'd say something like, you could get $20,000 scholarship if you're a math major. Check. You got this GPA. Barely. Check. You are interested in this. Check. Bam, 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 bam. And the last thing is you are a woman. I'm like, why don't you? I mean, this is actually a true story. This happened to me a couple times. The last thing was you are over 50% Native American or something. I'm like, put that damn thing first. So that's the and. That's and. There's a hidden and. You must be this and this and this. Every time I introduce a new requirement, how many people match that thing? Less and less and less. You with me? Here's another example I like to use. And is like the mean bouncer at a club. Or is the nice bouncer at a club. So the and bouncer would say, all right. So I walk up to the and bouncer, right? And he says to me, okay, to get in the club, you got to be dressed nice. All right, you lost me already. And you have to have a nice car, and you got to be rich, and you got to know Joe, the bartender. If all those four things are true, you can come in. So every time he introduces a new thing, how many people can come in? Less and less. It's a very exclusive little club. I'm like, screw your club. I don't want to be a part of it. All right. Probably water your drinks down. Go somewhere else. Everybody kind of with me here? The and says, in order to be in the result, you have to match all of the requirements. I like it. Or is the nice bouncer. So if the or bouncer said, you have to be dressed nice. Shit. You have to have a nice car. Shit. You have to be rich. Or you have to know Joe the bouncer. I'm like, Joe, hey Joe, I can go in the damn club, right? So every time he says this, or this, or this, or this, the number of people that can come in grows. Are you with me? And is always going to restrict. It's got to be present in everything, in every group. Right? Or says the other way. It says include everybody that's any part of any of these things. All right, so let's see what this means mathematically. Let's get away from bouncers and stuff like that, scholarships. All right. Another name for and is the intersection.
What page is it?
This is page 193. We're getting into chapter 8. Praise people we are. So intersection is another name for and. We've already seen the symbol for or. I know you guys remember this. The or symbol was like to skip a number when I do interval notation. It was a U.
Oh, yeah.
That U symbol was or. So I love that because it's like you or you. Somebody do it. Shit. So it's this shape, right? U for union is what's called, the or is called. Intersection, the symbol looks like, I was thinking it looks like an A for and without the little bar in the middle. That's the symbol for and. Looks like an A without the bar in the middle. Just trying to help you guys remember which is which. So I want to know the intersection, the and. What's in A and in B? Can anybody tell me? What is in A and in B? 1, 2, 3. So A and B would be the set 1, 2, 3. So this is the mean bouncer. You got to be in group A and you got to be in group B. You got to be rich and you got to know Joe. Right? So these are the 3 people that do both. You guys with me? And is always going to at least decrease the result. Or is going to increase the result. It's going to let more people in. So what would A or B be here? What would A or B? What would A or B be? A or B be? So A or B would include everything that's in both. It's not going to double include anybody. So it's going to be -4, -3, -2, -1, 0, 1, 2, 3. Now what do I include from here that I haven't already? 4, 5, 6. So you got to be in A or B. So all those people, all the people in A, all the people in B, they could come into the club. You could be in A or B and come in. Okay, let me stop there for a minute. Okay. So those are the symbols. That's the symbol we've seen before. That's the new symbol. It's kind of nice that it's sort of the opposite, so it just turns the other way. That's nice. So how does this stuff work here? Well, first off, I want you guys to do these two. Go ahead and just graph these two on those graphs next to it. That should not be a very taxing thing. Graph this sucker and graph that sucker. Be a little careful with this guy. Oh shit. This is kind of backwards. How should this be written so you go the right way? If -3 is less than x, then x is bigger than -3. There you go. So you shade the correct way. So greater than -3. What should go on the -3? We're beyond that shit, aren't we? Remember?
Oh,
Not an open circle anymore, but a
comma.
parenthesis. Right? So parenthesis there. And then it just goes forever up, right? Greater than -3. Cool? And the beautiful thing is the little inequality symbol looks like an arrow. So it's pointing in the direction you shade. Can't beat that. That's awesome. So x less than 2, what would you put on 2? Parenthesis again. Opening that way because you're going to shade that way. Now how would I shade -3 less than x and x less than 2? It's got to be, and now you see why the word intersection is so beautiful. So it's got to be the numbers that are in the shaded area in the first dude, and they have to be in the shaded area in the second dude. So what's the only numbers that do both? Yeah, what's in this one but not in that one? Everything below -3. So all those numbers are screwed. They're here, but they're not there also. So this is the club, this is the mean bouncer. It says you got to be in both. So what's the lowest number that I can use? -3. That's the lowest number that's in both. And what's the highest number that's in both? 2. See what the idea of intersection is so beautiful. Where do they intersect? They intersect right there. That's where they intersect. That's why the name intersection is beautiful. And the name union for or is beautiful because you unite the two groups together. Right? Okay. So this would be from -3 to 2. So and will pretty much always be that sandwich. It's a sandwich between these two. Sandwiched in there. There's my bread. There's my green jelly. Okay, I like it. And so you can see what's a better way to say this than that and that is just -3 less than x less than 2. X is between those two. I like it. So how are we feeling so far? The idea and, the other word for and is intersection that actually shows you what you do. That tells you what to do. So here, number 2. You guys do this the same kind of way. Solve this and then graph it. Solve this and then graph it. And then try to do like we just did. Try to get that result. So try to do number 2. You got to solve it a little bit. Not that hard. So I saw this bad boy and turn him around. So the end's on the right side. You guys are going to look at the correct side. If I graph this guy, greater than or equal to -5. That would be, what would I put on the -5? Bracket. Less than or equal to -1, so another bracket and down because it's less than. We okay with each of those? Separately, you just do separately. And now, what's the and going to be? So it's the lowest it could be. Yeah, -5 is the smallest number that's in both. And what's the biggest number that's in both? -1. All right. So here's that sandwich again. Yes, I am saying sandwich. A good sandwich, you call it a sandwich. This is a man sandwich, so it's damn good. All right. So what about or? Shit, does or work? Well, or is really great. You just include everything, both. So, x less than 2, -2, or x greater than 4, I just put this all on one graph. It could be less than -2, so how would I do that? What would I put on -2? Parenthesis. It could be less than -2, or it could be greater than 4. So x less than -2, or x greater than 4. Now, one thing I love to teach when you get to Math 110, or Math 103, is something called absolute value inequalities. And that's something we're not going to do. It's going to be left for the next section you take. But somehow I relate them to sandwiches, which I already did, and restraining orders. So, or, you notice how it's like, stay the shit away from me. Here I am in the middle. That's me. Good old number 1. And I'm like, stay away from me. You must stay at least that many yards away from me. You guys with me? Sometimes it's a little too close to reality for some people, but I like that idea. So an or will almost always be this, like that. An and will be stay near me, an or will be stay away from me. You guys see this? There'll be a sandwich for an and. It'll almost always be a stay away from me. Do you see that two separate sets? I love how you guys look at me right now. So how would I do this in interval notation? I would say negative infinity up to negative 2, or 4 up to infinity. You guys remember doing that before? Poor little infinity dude. It's very similar to some stuff we were doing earlier this semester. Alright, so you guys try to do this one. It's basically two separate problems that you solve, and then you do exactly like we just did. If you're not 100% sure how to do this, you should be able to do each of these separately. So at least do that much. Get that far. So notice something, the really nice thing with or is you could pretty much go directly to the number line. Because you just graph both things on. So I really want to make sure you guys, the or bouncer is going to open the door and just let both groups in. Anybody in either group comes in. That's why I can just grab that and just plop it on there. So getting into the club is equivalent to getting on the number line. So how do I graph this? I just do, yeah, negative 8. What do I put on the negative 8? Parenthesis. Less than. Yeah, this one doesn't have it. And then on the 5, I'm going to put a bracket. So there's that or, that visual of the or. So how would I write this piece in interval notation? Right here. Yeah? I heard it. Yeah. Negative infinity up to negative 8. Same symbol. Plot. Or bracket 5 to infinity. See how the or, remember what I called it before? I call it the skip. So go up to negative 8, skip to 5. I love that idea that the or is like skip. Skip all this in the middle. I like it. So the or is a nice bouncer, but if the thing is, you got to be rich or you got to know Joe, well, who ain't coming in? People that ain't rich and they don't know freaking Joe, right? They ain't getting in. So there will be people that can't get in sometimes. That's that middle group. That's why I skip them. Yes, ma'am. Oh, so the parenthesis, whenever you want to put an open circle like you did back in the past, that chop it in half, that's a parenthesis. And the bracket is like, the way I related it is, it's like the letter I for include, and then you erase part of it so it looks like a bracket. I like it. So that's how I try to tell people to remember it. Real quick, let me me see if you guys get this. What if this would have been this problem instead? Same problem, really, but it had and. This and this. What numbers are here and here? Which numbers are here and here?
Oh, none.
None. Good. So this would be no solution. So it's sort of like the bouncer saying, I'll let you in if you're over 7 foot tall and under 4 foot tall. And you're like, what kind of people are in that club? And you just crack the door open, let me take a look. There's people that are like phase shifting. Because, so there will be some special cases where the answer is nothing. There could be a special case where the answer is everything. Let me see if I can find one of those. Ah, shit. Let's see. Blah, blah, blah. Here. Why don't you guys try 3 and 4 real quick. See if one of those are interesting. I think 6 is going to be interesting. Okay. Just want to make sure. Real quick, guys, a good note to write is an and problem will never end up looking like this. It can't. An and will never end up looking like this. Does that make sense? That two separate stuff. It can't. Whereas an or almost has to. Almost always will. This is nice. This is good. So what do you guys get to this point here? Are you getting those?
Yeah, not get one.
So you add 7 over, it's -3, divide by 3, get -1. Subtract 220, divide by 5, 4. Oh, you only flip the inequality symbol when you divide or multiply by negative. So like there, it was negative, but I divided by 3. So then the order doesn't change. It's only when I multiply or divide by negative that it switches sides of the number line, which is why the relationship switches. I want that to make sense. As always. Now, what do you guys, did you guys try to start graphing this thing? Greater than -1. So that'd be like that. Less than or equal to 4. So that'd be like that. And this is where people get confused and they say the answer is this stuff in the middle. That would be if it said and. It says or. So this is a lot like saying you only get the discount if you're older than 8 or younger than 20. Everybody freaking gets the discount there, right? You guys, if you're older than 8 or younger than 20, who's left out? Nobody's freaking left out. It includes everybody, right? Even the people that ain't born yet, people that died, they're all included. You guys understand that? There's nobody who is not less than 8 or, I'm going to say greater than 8 or less than 20. You are one of those things. So the or says everybody then. I really want that. And is restrictive or is allowing things to happen, right? And says both of these. So if this would have been an and, the answer would have been this stuff right there in the middle. It would have been a sandwich. This is a special case. This is an or, so I include all this and all this. Well, what did I leave out? None. So how do I write the answer in interval notation? Yeah, negative infinity to infinity. So that is an extreme for the or. An extreme case for the or would be everybody gets in. Yeah. Either you make more than $80,000 a year, or you make less than $200 million a year. Well, that's everybody, isn't it? You do one of those two things. In fact, a lot of us do in between those two things. That's everybody. Please understand this, please. All right. What about number 4? Go ahead and finish that one up, or start that one. So let's see. So this one, you add 1 divided by 2, you get x greater than 3. This one, you subtract 2, divide by negative 3, so you get x less than negative 3. Is that cool? You guys get that? So it's got to be greater than 3. Good job, Joe. Greater than 3 and less than negative 3. So where's the intersection between those? There is no intersection between those, so what's the answer? No solution. Even better, here's the answer. Here's the symbol for the answer. This is why I told some of you guys to be careful how you write the letter. I love it, Joe. The number 0. That symbol means the empty set. So it's awesome. So the answer is the set of all numbers that make the thing work. And if there aren't any, then that set is freaking empty. And that's how we represent the empty set. Like giving somebody an empty bag and saying, all the answers I come up with are in this bag. Oh, you come up with shit. All right. Nothing. It says the empty sets. Full enough. Does everybody get that? Those are the 2 examples of extremes. Normally, an or will be this, and an and will be this. That's the normal way. These are the 2 possibilities for extreme. Or could be everything, because or lets more and more people in. So the extreme for it is just let everybody in. And is don't let anybody in. And then I'm not sure how your club makes money. This club, I don't know. Let's see. Blah, blah, blah. Ooh, all right. So you try that number 6 real quick. Let's see what's weird about number 6. If there is anything weird. It's a little bit weird, but we'll see. All right. So I'm going to do this problem, and I'll see what it would have looked like if it would have been and. So see how they're both going the same way? Less than, one's got a less than or equal to. So x less than or equal to 6. Negative 1, 0, 1, 2, 3, 4, 5, 6, yeah. That would be this, right? And x less than negative 1, that would be that, right? So this is an or. So it's just going to take both groups, but then what does it actually become then? So I want all these, or all these. So then it's just all these. These are already included in everything below 6. So sort of like I say, you could be on the team if you're older than 12 or older than 18. And you're like, well, just freaking older than 12 then. What's your problem? Why'd you say the other thing? Do you understand what I'm saying? A little bit? Now, what if it would have been and? What's the main idea of and is where they intersect. And where do these two intersect? What group of numbers is in both answers?
-1.
Yeah, this group right here, below -1. This stuff is only in one answer. So if it would have been and, the answer would have been looking like that. And is less inclusive. It takes less stuff, or takes more stuff. Or it takes everybody that's in either group. And takes only those that are in both groups. That is the difference. Okay. No, this won't help you buy lettuce in the store. I don't give a shit. There are the most immediate application, especially when we get into Section 8.3. Section 8.3 is related to safety zones, I want to say. So the opposite of danger zone. It's like in an elevator. Let's say you can only have so many people in an elevator, so everybody has room to freaking breathe. So there's a restriction, and you can only have so many people have it be a certain weight, or else the thing's going to plummet and kill everybody, even if they can breathe. You with me? So you have all these kind of restrictions, and so in Section 8.3, we're going to be plotting restrictions and kind of seeing where our safe zone is. So you're like, what the shit's that going to look like? Well, we'll find out when we get there. We're not going to do that today. I personally think this is probably enough for today. I want to say this. We do have quizzes coming this week. When's that next test? Yeah, the 5th, which is next. Is it next Thursday? Yeah. Whatever day it is, it's the 5th. So let's do a quiz. Oh, let's see. Yeah, that's better. Next Tuesday? Alright, let's do a quiz this. Yeah, we haven't had a quiz on this stuff yet.
Are we having a test on this section, or are we just doing it?
No, there is a test, remember, so that's going to be on Tuesday.
Oh.
Next Tuesday, there's a test on Chapter 7, Chapter 8. That's Tuesday. And then there won't be any new stuff. We'll just review, and then the final's going to happen to us. You guys go with me? A little bit? Following your little timeline, if you printed that sucker out for yourself. So let's have a quiz. Let's see. I'm just trying to figure out what days I want to make this quiz happen. Let's actually make it... Well, screw it. We'll make it Wednesday and Thursday. Wednesday and Thursday. I'll announce this in the labs too. And we'll do 7-1. Yeah, let's do 7-1 through 7-4. I should give everybody plenty of time to get that homework at least looked at. So ready for that quiz? All right. So So if you're in the next, if you're in the lab, it starts at 11. Just go slowly. Don't try to invade yet. Leave it a little early.
Practice for a timer or something? Or
Yep.
is it just okay, cool.
Yep.